cross-grid, but that's not the case, I think. Okay. Right. If there are no more questions, we'll go to the next talk. Now, the next talk is from Eric Boyd. And Eric Boyd is a consulting engineer with Internet2. Eric's not here. Eric is virtually here. And the subject of the talk is the area of pervasive performance monitoring, both from endpoints and at core points in network, in Internet2, in Geant, and so on. So, Eric, if you'd like to go ahead.
Sure. Can you hear me?
Very well.
Okay. Yes, so as Peter said, the topic of my talk will be the Internet2 end-to-end performance monitoring initiatives, latest projects, giving a bit of an update. I just want to thank Peter for asking me to do this talk. I had a good chance to meet with this group last week, and I should appreciate the collaboration. And hopefully, if people are interested in this talk here today, there might be other areas of collaboration as well. So feel free to ask questions. Maybe a little difficult during the talk, but if it's important, please do. And at the end, there will be questions, and I'm also available via email if you'd like to discuss this further. So just to give you a brief overview, these are some of the areas I'll be talking about today. Let me just give you a little bit of background. Internet2 is the organization here in the United States that works on the high-speed connectivity between universities and our corporate members. We sort of have the Abilene backbone to give you the network. We have groups working on the applications and middleware. The end-to-end performance initiative in particular is concerned about, well, if you have the applications and you have the network, just, why don't we always get the performance that you might expect that we should be able to get? So let me go a little bit into the motivation. I will explain these acronyms, PIPES and AMI and OAMP as I go, and just give you a little bit of a sense of what we're working on here. So the context is, even with these high bandwidth network links, our community often does not see the expected performance, so we need to address that problem. This is a slide from Matt Mathis at the Pittsburgh Supercomputing Center. The idea here is that there's a gap between what you can get sort of with out-of-the-box performance versus a highly tuned system. Ideally, these two lines would be at least parallel, if not on top of each other. So our goal is to move the lower line up to and parallel with the upper line. That would be eliminating the wizard gap, as it were. So this is an old slide some of you may have seen, but the idea is basically when you do have an end-to-end performance problem, it's often very difficult to solve a problem along that end-to-end performance path. If you ask any one person, they all say, basically not our fault, yet it's quite apparent to the end user that there really is a problem. So how do we address this problem? So I'm going to be talking about some of the projects that we're working on here, and we're doing collaboratively with other groups, but I certainly don't want to imply that this is the only approach. There are many projects and research going on elsewhere in the United States, in Europe, and in the world. And we are seeking really to, A, understand what other groups are doing, B, try to bring those efforts together, and really make it, so we're not sort of duplicating each other's work, and try to look at the end-to-end path as a complete system. So to quote Terry Gray from the University of Washington, we need a finger-pointing tool. Basically, when you do have an end-to-end performance problem, you need a tool to tell you where the problem is, sort of roughly what type of the problem is, and who to contact to get it fixed. So going back to our original slide, if you're the end user and you want to find out where the problem is, you would do something like this. You'd like to be able to say, this is where the problem actually lies. So let me get a little bit into pipes and the Abilene measurement infrastructure and give you a sense of what they are. And this is probably a good point to hop up one level and sort of say, I'm going to be talking about the pipes project here today, as well as the AMI project, as well as the OAMP project. So there's sort of three different things that Internet 2 is interested in that are all overlapping. The pipes project is basically an attempt to stitch together the ability to do link level analysis across the entire end-to-end path. As one component of that, we would like to instrument the Abilene backbone with what's sometimes called the Abilene Measurement Infrastructure, or has also been termed the Abilene Observatory. And then we would also like to contribute a tool to that effort to do one-way pings, basically, called OAMP. So I'll get into each of those a little bit, but I just wanted to set the context. So the Backbone Network Infrastructure Group here at Internet 2 is interested in instrumenting the next generation Abilene with basically extensive performance measurement capabilities. And they've done a lot of planning towards that and actually co-located next to each of the routers in the Abilene backbone are a set of machines that can do performance measurements. So building this is actually a good first step in pipes, which I'll get into in a second. So, within the end-to-end group, we're sort of using this as our starting point to build the pipes network out. So this is really a collaborative approach within Internet 2, the Backbone Network Infrastructure Group, engineering, as well as the end-to-end performance initiative. So the pipes project, and I'll freely admit I made up the acronym first and then the definition later, but it stands for the Performance Initiative Performance Environment System. But what I really am trying to convey here is that it's we sort of think of the end-to-end path sort of as a pipeline of varying thickness. That's where the motivation for the name comes from. So our goal is basically to allow end users and network operators to determine, what is the capability of my network, where does a problem lie, and who would be the right person to solve that problem. So in a sense, we're setting a slightly lower bar than what is the problem and how do I fix it explicitly. We're more envisioning the situation where today someone who is not necessarily a highly trained network engineer experiences an end-to-end performance problem and they're trying to get it resolved. And their experience is, I contact my local system administrator who says there's no problem. We go back and forth. We finally agree there is a problem, but I should call this next person, then repeat ad infinitum. So setting the bar a little lower than actually fixing it, if we could at least get that person the name of the right person to solve the problem and start looking into it first, and give them the ability to sort of say, and here's proof that I do have a problem, that would go a long ways towards eliminating some of the frustration. And as I mentioned earlier, this is definitely a collaborative project. Our aim really is to find other organizations out there that are doing similar work or are interested in these topics and work with them. And basically, whatever projects they want to do from a research standpoint is great, and we'll try to fill in the glue sort of, or the nuts and bolts that aren't as interesting research-wise but need to get done, and try to stitch the whole thing together. So as I mentioned, the new Abilene is going to basically have a bunch of measurement devices as part of its structure. So if you think of each router plus the associated set of one or more measurement machines as a performance measurement point, or a PMP, we basically will be able to run regularly scheduled tests between the Abilene nodes. And I should mention that I'm sort of using PMP here to sort of mean the whole measurement system, the box, the test itself, any scheduling that needs to get done. But in a later slide, I'll sort of refine that definition. So if you're going to do this between the Abilene nodes, why couldn't you also perform regularly scheduled tests to the campuses, is sort of where the root of the idea comes from. And basically this is an example of doing that, so you could get a sense of what the capability is and the like, and run regularly scheduled tests. So if you're going to extend it all the way to campuses, then the thought comes, why not extend it all the way to the end user as well. Now, you probably wouldn't have regularly scheduled tests between the end user and the campus edge, but you could run an on-demand test, say between host A and campus X PMP, and then stitch it together along the rest of the path. And if you're going to do that, then why not sort of put all the major intermediate nodes as well into the path? So you really now give yourself the ability to do link level analysis. So sort of popping up one level, imagine ideally if you could do a trace route, and you could see the entire end-to-end path, and then you sort of had super user access to any router along the way, or rather a machine located next to any router along the way, and you could run any test that you wanted between any two of those nodes. That's sort of the idea of what you might start to be able to get. So there are regularly scheduled tests between each of these nodes, and then there'll probably be, not shown, some longer tests as well to sort of sanity check the nearest neighbor test. So once you do this, the idea of the pipes project is that you would be able to say, well, look, the problem seems to be in the neighborhood of the yellow PMP there, and therefore the person best suited to start looking into the problem is the appropriate contact at Gigapop T in this example. And then once the results are sort of passed, then you can sort of pass on to that person a convincing case by saying, these are the test results we've run, and this is why they come to the conclusion that we think you should start looking into it. So really the idea here is if you improve the signal-to-noise ratio of emails coming into network operators, where an email comes in and a person says, I think you're the best person to look at this problem, and here's a convincing case why, then they're more likely to trust the reports from a tool that does that. So this is a sort of high-level overview of the pipes architecture, and it's evolving. Peter will recognize that this diagram is a little different. It reflects actually a little bit of a discussion we had with his group last week. So there may still be some changes to make in it, but it at least gives you a sense of where we're at today in terms of understanding how this is going to work. If you look in the top center of the picture, you'll see it says end user interface. So basically, what I'm going to do here is sort of give you the high-level vision, and then later I'm going to talk about the specifics of what we're actually going to try to get done in the immediate near future and give you a sense of how we're going to build out to this. So the idea is that an end user would have some sort of end user interface, possibly the advisor tool being worked on by the NLAN or DAST folks. And as part of that end user interface, they would be able to specify the endpoints of their end-to-end performance problem, as well as the type of application that they're running, whether it be video conferencing or bulk FTP or the like. That sort of request is passed to the testing engine, which decides how it wants to approach the problem. Rather than say, I need an iPerf test between this node and this node, what the testing engine actually says is, I need a latency result or a throughput result between this node and this node. So you basically are requesting a test result. That request is passed to the appropriate administrative domain, which basically decides whether or not the test request is authorized and whether or not sort of both ends of the test have the ability to perform the test. For instance, if you wanted to run an iPerf test, you'd need sort of the iPerf software installed at both ends. Once that's sort of agreed on, then it basically, what I call here a PMC, or Performance Measurement Controller, takes that request and schedules the actual test in a way that does not disturb any other test going on concurrently. For instance, you wouldn't want to bombard target PMC with too many large iPerf tests simultaneously. So there is some scarcity of resources. And then once that test is scheduled, then the actual test is performed between the source PMP and the target PMP. So really the domain interface, PMC, and PMP, if you lump that all together, is what I was showing you as a PMP in the earlier diagram. And the reason we sort of blocked it out like this is to give you flexibility in terms of how one might set up an administrative domain and the like. So once the test is actually run, The data is passed through a database gatekeeper back into the performance database, and that could be a real single database. It could be multiple databases. Sort of as long as it's accessible, it doesn't really matter. And then passed back from the database gatekeeper back through the source PMP, source PMC, and domain interface is the fact that either the test result exists and it's ready. You weren't authorized to have that test performed, or that please be patient. When the test result is done, I will notify you as such. So once that test result is done and the analysis engine is made aware of the fact, then the analysis engine can sort of figure out where it thinks the person most appropriate to solve the problem is. Then the idea we have is that there's also a sort of what we've been calling a culprit database, but this would be a database of contact points that people voluntarily supply their contact information, probably something like problems at gigapop.t, .edu or something like that. But the idea there is that if we really are producing some useful results out of this tool, or improving the signal-to-noise ratio, then it's worth their while to listen to reports coming in from this tool. And then at the very bottom, you'll notice sort of I have the idea of a human analysis engine. And I'll get into this more, but sort of in a later picture, you'll see we're sort of working on the lower right part of this diagram first. And before we get to the left-hand side, we sort of will be making this available via web page. So at least you have, if you're an expert user, the ability to get to the data quickly and do your own analysis in the absence of a software package to do it for you. Okay, so I'm going to go through a couple slides here that sort of tell you about some of the open research questions, just to sort of give you a sense of the scope of the problem that we're working on. Matt Secaucus is one of the network engineers here at Internet2, and I like to tweak him with this slide. But the gist of it is that most people, when they have an end-to-end performance problem, do not have a highly trained network engineer standing next to them to solve their problem for them. So they need eventually sort of a automated testing analysis engine. So some of the open questions are, if we pick an application family like video conferencing, what measurement results are sort of acceptable for that? What is an acceptable throughput and latency and all that? So once you've decided that, which tools generate the results that you need to decide if a link is going to be good enough or not? What do you do in the absence of complete data? What if you have multiple different tools that generate the same result? How do you sort of score a one-way ping tool versus a two-way ping tool and that sort of thing? And then how do you sort of encapsulate the problem-solving approach a network engineer would use to create an iterative decision tree to go about sort of locating where the problem is? Some of the measurement schema questions are very closely related to the GGF efforts, and I should probably talk about that a bit. We're trying to work closely with the GGF, specifically the Network Measurement Working Group. They've got a lot of excellent work done, but a lot to go, some of which we need the answers to already. So we're trying to work with them, use the work that they do have done as a starting point, contribute back feedback and suggestions on that, and also help them develop future documents as well. There are questions of measurement units, mapping tools to measurements, how do you set up the database, all sorts of things like that. There is a bunch of AAA questions, or access, authentication, and authorization. We sort of have the idea that we don't want some undergraduate in the middle of the night to be able to run a huge iPerf test between two Abilene routers. We want to have the idea of roles. So, what can a standard end user do? What can a network engineer do? What can a network engineer in an administrative domain sort of nearest to your administrative domain do if you have a high trust relationship? The middleware group here at Internet2 is working on Shibboleth, and we may use that for some of this. There's some other efforts as well that we're aware of. But the gist of it is that we want to have the ability to couple roles with what administrative domain someone is coming from, and from that determine whether or not you are allowed to request an on-demand test. Our idea is that most of the time you'll be using a regularly scheduled test result that you're pulling out of the database that already exists, plus a couple of on-demand tests between your end nodes and sort of the campus edge. Other R&D issues that come up are obviously how do we make the system scalable. If it's only for the Abilene measurement infrastructure, that's one thing, but if it's going to scale to sort of the entire Internet 2 community or the European community as well, how do we sort of minimize or eliminate centralization? Obvious points are, it's easy to centralize the scheduling. It's easy to centralize the database the data gathering into a common database. But how do we make sure that the system's really going to work? You can't just do a trace route today and say, if I do a trace route between Ann Arbor and Zagreb, I don't sort of find out the name of useful measurement point systems sort of co-located next to the router along the path. So how do you discover those PMPs on the way? If you've got a sort of a pattern of regularly scheduled tests going on already, how do you insert on-demand tests into that pattern without disrupting the existing tests and destroying the integrity of the data? And then, as I mentioned, balancing the centralization and distributed database requirements as well. So what I'm going to do next is I'm going to go into what we're actually planning on rolling out in the immediate future and what the step-by-step plan is towards that and what we've accomplished so far. I'm going to talk very briefly about OAMP. There's a website you'll be able to find out more about that, and then time permits, I'm going to give you a brief demo at the end. So this is the diagram you've already seen before, but you'll notice now sort of the bottom and right sides are in red. So that's really where our group at Internet 2 is focusing its immediate effort, and more specifically, we're focusing that in the Abilene measurement infrastructure as a starting point. Now, we're fully aware of the fact that most end-to-end performance problems are not in the core, but they're actually on the edges. But given that we also have this charter to instrument the Abilene measurement, the Abilene backbone, it's useful for us to start in the center and then quickly work our way to the edges, as opposed to starting the edges and work our way in. But I didn't want to give the wrong impression there. Just sort of to the left of the source PMC and target PMC, the domain interface part, that is an area of interest to some of the folks at SLAC, as well as some of the folks at the University of College London, and they'll be working on those areas. The end user interface is an area of interest to the NLAN or DAST folks, and I know they're making a lot of efforts in that area, plus a lot of their own additions with the advisor project as well. So the rollout that we have envisioned here is first basically getting OAMP, which stands for One-Way Active Measurement Protocol, or basically one-way ping, and I'll talk about that a little bit more in a minute, up and running between the Abilene measurement infrastructure nodes. That is happening, and the data is being gathered into a performance database, and there is a visualization package or sort of human testing and analysis engine in existence. We've been working with Warren Matthews at SLAC to put together sort of a web service front end of that, and he's made good progress on that, and is also working with a variety of the areas that SLAC is interested in to consume some of this data. I believe right now he's working on feeding it into Mona Lisa and some other projects as well. So what we're in the middle of right now is getting iPerf tests running as well and traceroute tests running as well. Now, for the short term, we're going to just actually run traceroute between the nodes, but the long-term plan is to actually query the routing interfaces and do it that way and be able to actually catch stuff, changes in routes that last only a brief amount of time. So that's what we're in the middle of. And hope to have done by this summer. In addition, what we're working towards this summer is sort of an early demonstration of the viability of this approach approach by rolling it out to at least 2 campuses and being able to do an end-to-end performance case study. And then, finally, what we'll be working on in late summer is the ability to insert your own on-demand tests into this system as well. So I won't spend much time on this, but we've basically put together a testing environment because we need to both have this live and working, so we sort of have a mini Abilene backbone measurement infrastructure, and then the ability to roll it out to the whole thing. So just to give you a sense of some of the resources, so if you run into some of us at conferences, you'll be able to buttonhole us on that. There's myself doing development and project coordination, Jeff Boot, who's been focusing on OAMP and doing development, Prasad Kalyam, who works with us from the Ohio iTech, halftime for us and halftime for them. We've got folks within the BNI group, Chris Herman, who's interested in the Abilene measurement infrastructure, Matt Secaucus, who's sort of serving as our resident expert. We've got tech support, Russ Hobby with Susan Evett. Russ Hobby is working on rolling this out to the campuses and making sure we have a plan for that. And George Brett is helping us coordinate with the GGF. In addition, we've got some folks that Peter has offered up very graciously to work with us. Warren Matthews at Slack, as I mentioned, and we just had some good discussions with the folks at Dante that I think we'll also be able to do some fruitful collaboration there as well, although that's just in the early stages. So OAMP. So just to give the context again, Internet 2 is interested in stitching together the PIPES project to allow you to do link level analysis between your 2 end nodes. Towards that end, Internet 2 is working to contribute its part of the instrumented link level analysis, i.e. the instrumentation of Abilene or the AMI. And the idea is that this framework will be able to allow multiple tools, such as iPerf, such as Traceroute, or whatever, and new tools as they're developed, to be able to be run but between different systems. One of those tools that we think should be run is a one-way ping tool. And there's an effort to standardize a one-way active measurement protocol, which is where OAMP comes from, which is now possible due to the growing availability of good time sources, with the idea being that if there was wide deployment of open servers that allow measurement of one-way delay and they're commonplace, then a protocol such as this would be effective in allowing people to regularly do one-way ping as easily as they do two-way ping today. So there is a draft IETF spec being worked or being submitted by 3 of the folks here, Stas, Ben Teitelbaum, and Matt Secaucus, and that's available with Google search. Jeff Boot has been working on a reference implementation of this and has actually released that in beta right now. It's all but in first release. The gist of it is that it's an NTP system call interface, so there's a variety of different ways to do, to build in behind the timing. It's got multiple processes for receive and send loops, and it's written as an API to allow one-off implementations. So if you want to find out more about OAMP, there's a sample implementation in beta release available here. And please do take into account the caveats of there's no policy or authentication or encryption right now, so you probably only want to run it behind your own firewall. So within Abilene, the way we're rolling out OAMP is we're doing 2 full overlapping meshes, one IPv4, one IPv6, and with 11 measurement nodes, that gives us 220 ongoing tests. We're setting UDP singletons at a rate of 10 packets per second. That may have been scaled down to 1 packet per second. And the results are then sort of continuously streamed back into the database. So let me go to a demo, if we still have time, Peter. It'll only take a second. See if I can get this.
Thank you. Yes, you do.
Okay. So the idea here is we want to give a snapshot understanding of how the Abilene backbone is doing. And want to give experts the ability to quickly mine get into the database without a lot of layers of obfuscation. So this graph is actually more colorful than once the system is really stable and fully deployed will be. And it will continue to evolve over time in terms of what the red and the green and the black mean. And we'll probably introduce the color yellow eventually. For now, this is sort of a prototype, but the idea is that these are the Abilene measurement nodes. And if there is no data being collected, then the node and the links to it are black. If there is data being collected and it's good data, then it's green. And if there's any loss, then we start as red. Let me see here. So the idea would be that we'd have hot links between any two nodes, and you can sort of see, this is the one-way delay. This is a very boring graph, which is good, between Kansas City and Indianapolis, for the time period selected. So this really only gives you sort of nearest neighbor data. The reason for the sort of confusion of lines here is that we actually have Kansas City and Sunnyvale as nearest neighbors, as well as nearest neighbors with Denver. It all overlaps. So you'll be able to select a time frame, either sort of current time, the set of recent time, pick a specific end date, or pick a specific range of time. And once you pick it here, it sort of continues to follow you through the multiple screens. So this is an example, again, of sort of the full mesh of data. Notice we have V4 data and V6 data. Here, if it's red, it means there's loss. Right now, we're really only showing you minimum delay and loss. So it's not the not the most interesting set of data that we eventually will have. We are actually gathering much more than that, like 50%, 90th percentile. We just haven't been in the office enough to get that into this demo. But if, for instance, again, you want to mine that, you can quick hop to a chart representing what that has. So that's sort of where we're going. And if you'll recall back here, so that would sort of be this area down here, the human analysis engine and web-based display engine, which will eventually be replaced by what we envision of an automated one, but that we wanted to get something up and running to begin with. So jumping to the end here, you can get more information. There's the Internet 2 web page I have there. There's also a specific end-to-end performance initiative web page, and all updates and progress will be reported there. And you can also contact us via email. You should also put my own email there as well. And I guess with that, I'll stop and take questions.
Thank you very much, Eric. If we can. So, questions, please, for Eric? Yes. And
Hi there. On any given internet work, it's very likely that different routers along the hops will have different policies for dealing with different types of traffic, given the type of the traffic. So, for example, ICMP will be treated very differently from your application layer data. Are you concerned that this might invalidate your results?
I was having a little bit of trouble hearing the question, but if I understood it correctly, you're basically saying that as you go to different administrative domains, they may have different policies about what tests are allowed?
That's correct. Yeah, that's correct.
Okay. Our idea there is, we need to be able to operate in the absence of incomplete data. So there may be some administrative domains, for instance, that don't have any data at all coming out of them. Most domains, we're hoping, will at least allow regularly scheduled tests so that you could pull out the data that you want. There definitely will be issues with coming up with a meaningful conclusion if you have heterogeneous gathering systems. For instance, if you were running a end-to-end test between the United States and Europe, and in the United States we were using OAMP for a one-way latency, and in Europe we were using, I'm blanking on the name, but whatever RIPE uses to do its one-way latency measurements. So yeah, that is an area of concern that we're looking at. I don't really have, sort of an assurance yet, but that's something we're working towards.
Right. And how are you going to deal with the fact that, for example, ICMP, because you're using ICMP for measuring delays and latencies and so on, how are you going to be sure that the routers at each hop aren't just delaying it because they've been told to, as a matter of policy? Do you see that could create problems?
I understand. Yeah, actually, I think we're going to try to avoid using the ICMP ping as much as we can. We're going to be trying to use OAMP or similar ones that are just a UDP packet.
Okay, thank you very much.
Thank you. Other questions? I'd just like to make two comments with an application. Oh, sorry. Well, I'll let the audience speak first, then I'll speak at the end here. Can you give me the microphone? There's another question for you, Eric, from the audience.
That question is coming back in my mind because of the ICMP. Is there any measure of guaranteed security, in your protocol, so that it's not subject to denial of service or such kind of things?
Yeah, I didn't get into that too much, and to be honest, we've sort of had placeholders there for a while, and Peter can attest that in the last week we've actually spent quite a bit of time on that. We sort of are concerned about two levels of, I guess, denial of service attacks. One is, first and foremost, we absolutely do not want this network to be able to use sort of as a relay to, broadcast an attack. So we have built into it, the whole idea of having roles and requiring authentication. First, we're only going to permit tests to other participating tests. And second, we're only going to, even permit the generation of those tests if you are trusted by the two endpoints, basically. So, as I said, there's sort of two things we're concerned about. One is absolutely we cannot build this so it can be in any way used to launch an attack. And then second, we would prefer if this was not easily subject to a test. So one of the reasons for that domain interface is sort of to cloak where exactly the testing points within an administrative domain lie, so that the IP addresses of those machines are really only given out if you sort of get through the gatekeeper of the domain interface.
Thank you. Thank you. Okay. Well, my comments are only going to be from an applications point of view. This is very welcome because it will allow us to do some much more joined-up diagnosis of why things don't appear to be working for applications, and that's the interest in grid applications being involved in this. And the other comment is just to emphasize that discussions have taken place there's a similar group in TFNGN working on similar goals, and that's Nicholas Simha. I don't know if he's in Nicholas and Victor Rice in particular, I know, working on that, but they've been talking with the Internet 2 people. Okay, we'll now move to the... Oh, yes. So, David. Final question from David, or comment from David.
Okay, and then I had one other statement as well, too.
This is too conventional, but I was actually very impressed by the quality of the video conferencing, especially compared to the first plenary session this morning. Can somebody tell me how much bandwidth we're using for this? 1.5 meg. Okay, that's quite impressive.
Yeah.
Thanks.
I was similarly impressed. Yes.
That is impressive. I'm glad that the presentation was able to come across, and thank you very much for giving me the opportunity to do so. I do want to emphasize that this really is an open project. We're going to be releasing it all open source at the end, but we would like people's participation and comments early on. So please feel free, if you are interested, to get in contact with us, and if there's an aspect of the problem that you'd be interested in working on, we'd be more than welcome to have your participation. And again, thank you.
Okay. So the final talk of today is on the data tag project. TAG stands for Transatlantic Grids. Also, like other things, probably the acronym came first. The data tag project is concerned with two things: interoperability between grids on different sides of the Atlantic, and issues in the realm of the use of high bandwidth delay links for grid applications. And so to talk today is Jean-Philippe Flatin-Martin, who is the technical manager of this project based at CERN.
Okay. Does it work? Can you hear me?